Stream channel response to land use change. We know that vegetation removal decreases transpiration, increases runoff and erosion, and can definitely increase a stream's discharge and sediment load. Turns out that sediment supply and discharge can have a pretty big effect on channel shape. There's a lot of different ways to measure channel morphology, but we're going to stick to width and depth for right now. Conceptual models are used to show the relationships between factors and how they might change with respect to one another. This model is saying that discharge is directly proportional to width and depth, since they're all on top in this relationship. That means that an increase in discharge is likely to result in an increase in channel width and depth. Okay, here's an example of how land use change impacted channel morphology. In the mid-1800s, a lot of the native vegetation in the upper Mississippi River was removed and replaced by cropland and pasture. We'll look at a catchment that's a pretty good representation of the land use change throughout the larger watershed. In 1832, almost 100% of the Bear Branch River catchment was woodland and prairie. By the 1960s, woodland was reduced to 3% and prairie was completely replaced by cropland and pasture. This is the cross-section of a tributary in a similar catchment. The removal of vegetation increased the surface runoff and soil erosion, and in turn increased stream discharge and sediment supply. Higher stream flows and sediment concentrations meant more floods and more floodplain sedimentation. Bank heights increased and channels got a little wider as the erosive power of stream flows increased. Accelerated floodplain sedimentation increased until most flows could no longer overtop the banks. Without access to the floodplain, the energy of high flows became concentrated on the banks and the channel began to erode sideways. This lateral channel migration continued to widen the cross-section and increase flow capacity. Channel migration led to the development of a meander belt with a huge capacity capable of preventing large flows from becoming floods. So, from 1832 to 1990, channel cross-section increased from 3.6 meters squared to 24.8 square meters in response to the removal of native vegetation for agriculture. This is consistent with the conceptual model relating discharge to width and depth, only the increase in depth was due to all the floodplain sedimentation that increased bank height and not downward erosion. Either way, an increase in tributary channel capacity means more water is delivered downstream, causing an increase in flood frequency and magnitude.